Hello everyone. We are going to start our lectures on chapter 8, which covers topics from geometry. Now the first section of chapter 8 of course starts with the basic units of geometry, which are points, lines, planes and angles. We are not only going to look into the definition of each, but also understand what they mean from a geometric and mathematical standpoint. So in this section of this chapter, we will first define points, lines, planes, and angles. And then once we understand the definition of each, we should be able to recognize and solve problems involving points and lines, do the same involving planes, and then we should be able to recognize and solve problems involving angles. Now in geometry, the basic building blocks of shapes and figures are points, lines, and planes. These are three basic terms in geometry, and it's very hard, so to speak, to define them, but we should be able to recognize them when we see a point or a line or a plane, right? But the definition of them become a little bit abstract. All right, so let's go on to see how best we can get an understanding of these three terms. So even though we said that it is hard to come up with the definition of a point, we can look at some properties of a point. All right, so let me pull up all the information first, and then we will go through it one by one. All right, now any point is actually a building block of shapes in geometry, just like atoms are building blocks of all matter in this world. Similarly, a point is the building block, the basic unit of any geometrical figure or shape. And a point does not have a size, it does not have a shape, a definite shape, and it does not have any dimensions. All right, a point is really invisible, but to make it a little more concrete, all right, it is an abstract concept, but to make it a little more concrete, we denote it by a small tiny dot, like a speck, right? Just to make it a little bit concrete to our minds. All right. Now, a line is a set of points. So if we have a bunch of points and we connect them together, what we get is a line. All right. So a line, and sorry about that figure. All right. Let me try to do a better job with it. So if we have lines, a bunch of points very close to each other, maybe here. I don't know if you are able to see it. And then if I connect the dots, all right, what I will get is a line. All right, and the line can keep going in either direction, and we mark the end points with arrows denoting that it extends infinitely or indefinitely on both ends. All right, so a line is a set of points, not just 2 points, but an innumerable number of points, right? Now, any two distinct points determine a unique line. So we can have a line this long, or we can have 2 points very close to each other, and if we connect them, all right, if we connect them, we will get a line. All right, so any two distinct points determine a unique line. Now the third bullet says here, any point on a line separates the line into 3 parts, the point and 2 half lines. So again, let's draw a line here. All right, we have a line. And if we just pick any point on this line, maybe this point here, all right, this point divides the line or separates the line into three parts. One part is, just a second, one part is from the point to the left end, all right, that's part one. And then the dot itself, the point itself, is a part. And then from the point to the right end is the third part. All right, so again, we see that a point would divide a line into two parts. One part would be from the point to the left end of the line. That's part one. And the point itself is considered to be a second part. And then the third part is from the point all the way to the right end. All right. So any point on a line separates the line into three parts, the point and the two half lines. Then we have another term here called array. Array is a half line including the end point. So if this is the end point, or let's just mark an end point, another end point here, maybe this. All right, and we label these points A and B. All right, so array is a half line including the end points of the line. And a line segment is part of a line between 2 points, including the end points. All right. So given this understanding of points, lines, rays, and a line segment, let's see how we can draw a figure of these different concepts. All right. So here all the terms that we learnt about in the previous slide are represented symbolically. All right, so a line AB. So you see over here in the diagram, the line extends beyond the 2 points A and B marked by these arrows. That means it keeps going indefinitely on both sides. However, we pick 2 points on the line A and B, and that represents a line. All right, and then ray AB. A ray is again a line, a portion of the line that goes from A, from this endpoint. So see, this line does not extend beyond A. All right, it's at A, it starts from this point A, and then it goes up to B, but the line does extend all the way to the right. So that is considered a ray. Ray BA, on the other hand, is the end point of the line is B, and then we pick another point which we mark as A. So BA is a ray, and then look on the left hand side, the line goes beyond A, goes all the way to the left. All right, and then line segment is a line that whose end points are A and B. It does not go beyond B to the right, it does not go beyond A to the left. So that's what a line segment is. So this is how we represent them symbolically. So we have AB, and over here this line actually it has arrows over it. All right, so here we go. It should be, and it's not too visible, but they have arrows at both ends. That's how we indicate a line AB. And then we have ray AB, and it starts, there's no arrow on the side of A, but there should be an arrow B at B, or on the side of B on the right hand side, because the line extends beyond B. Likewise, over here for BA, the line extends beyond A, so here we should have an arrowhead. All right, and then for line segment AB, there are no arrows. All right, on either ends because the lines stop, end at A as well as at B. All right, so hopefully this gives you a better idea of how we define or the concept behind lines, rays, and line segments. Now that we understand a little bit about the properties of points and lines, we will go on to discussing or understanding what a plane is. All right. Now, previously we said that points do not have size, dimension, or shape. Right. It is considered to be a zero-dimensional figure, so to speak. A line, on the other hand, so this is zero-dimensional. It does not have any dimensions. Lines, on the other hand, is one-dimensional. All right, it just extends in one direction. It's one-dimensional. Planes, on the other hand, are two-dimensional figures or two-dimensional surface that extends infinitely in both directions. All right, so a plane will have length as well as width. All right, so it has two dimensionals. A line extends only in one dimension. All right, that's why it's a one-dimensional figure, whereas a plane is a two-dimensional surface that extends infinitely in both directions. Any 3 points, right? Any 3 points that are not on the same plane, or sorry, not on the same line, are called non-collinear points, determine a unique plane. All right, so if you have 3 points, again, it has to be 3 points, because if there are 2 points, 2 points can always be connected with a line. So any 2 points form a line or can form a line. However, in order to create a plane, you will need at least 3 points. All right, so if you have 2 points like this, just 2 points will form a line. However, if we have another point which is not on the same line, all right, which cannot be connected with the same line, let's say something here, then what we now have is a plane. All right, it's a plane. So I'm going to label these points, let's say A, B, and C. All right, so we'll notice that A and B can be connected by a straight line. A and C can be connected by a straight line, and C and B or B and C can be connected by a straight line. However, if you want to connect A, B, and C, then it's not going to be a straight line. You have to go up like this from A to B, and then you have to have another line from B to C and another line from C to A. So there are 3 distinct lines. All right, so that is what makes a plane. Any 3 points that are not on the same line, and that means they are non-collinear, determine a unique plane. So here we have 3 points A, B, and C, similar to what I drew to explain this to you. This is a plane. You see over here this rectangular box within which A, B, and C lie. All right. It has a width, a length. All right. So this is what makes the plane two-dimensional. So we learned that a plane can contain points within it, and when we connect those points, we will have lines also within the plane. And when we have a situation where we have 2 lines that never meet, they never intersect, then those lines are called parallel lines. So as long as the lines are within the same plane and they never meet, they never intersect, they would be considered parallel lines. So we will be learning some geometry on parallel lines. So it's important to understand the property that parallel lines will never meet, but they have to be within the same plane. All right. Now, a few other things about a plane. It says here a line in a plane divides the plane into three parts, the line and two half planes. So here we have this rectangle or parallelogram, so to speak, and we draw a line through the plane. And what happens is this line divides the plane into three parts. One half to the left, one half to the right, and the line itself is the third part. Now, we spoke about the same thing for lines as well. All right. If you recall a few slides back, we said that in a line, all right, a point on a line divides the line into three parts. The section of the line to the left, section on the line to the right, and the point itself is considered another part. All right, so it's the same thing when it comes to planes and lines, right? Now, a couple of other things about planes that we need to know is any line and a point not on that line determine a unique plane. Another thing is the intersection of two distinct non-parallel planes is a line. So here we have a figure showing two planes. The one is a beige rectangle and the other one is the greenish rectangle, and we see that they meet at a certain portion. All right, they have a point of intersection, not just a point of intersection, but several points of intersection that can be connected by a straight line. All right, so the intersection of two distinct non-parallel planes is a line. So when we have intersecting planes, then the connection is a straight line. All right, whereas when we talk about lines, we can have intersecting lines, correct? The intersection between two lines, that point of intersection is a point, whereas the intersection of two planes is a line. It's a line. All right. Now, another thing to know about planes is that when two planes do not intersect, they are said to be parallel planes. So here in this figure, we see that there are two planes. One is the pink plane and the other one is the blue plane, and they run parallel to each other. These two planes will never meet, right? So this is a box-shaped figure. So if you look at any cardboard box, the two opposite sides of the box will be considered to be parallel planes. All right. Now, another fundamental geometric figure is an angle. What is an angle? How do we define it? It is the union of two rays with a common endpoint. So recall that rays are essentially lines or line segments. A ray starts at one point and extends indefinitely in one direction. All right, that's the definition of a ray. It starts at a single point and extends indefinitely in one direction. Angles are formed by two rays intersecting at a common point. All right, so here in this figure, we have 3 points. B is the connecting point between these two rays. And look at how they have denoted the rays. Starts from B, connects with A, and extends in one direction. And how do we denote that? Using the arrowhead to that line. All right. And then for the other line, B and C, it's the same thing. One end is fixed, B is fixed, and then it connects with C, but it extends in one direction also beyond C. All right. Now, these are some terminologies that we must know. right? So we have the initial side, which is usually horizontal, all right? It's a horizontal line. And then the other line meets, like the line BA meets with BC at an angle, and that angle is represented as X. All right, so the angular um, line, all right, the line that meets at an angle, that is considered to be the terminal side, and that point of meeting is called the vertex. So B is considered the vertex. This line or this ray BC considered to be the initial side, and then BA is considered to be the terminal side. So we should be familiar with these terminologies, all right? Now, angles can be measured based on how much the terminal side has rotated from the initial side. Now, recall that angles are made of two rays, and one of the rays, the initial side, the ray which is called the initial side, is positioned horizontally, and the other ray is the one that rotates from the initial side, and to the extent that it has rotated from the initial side is the measurement of the angle. All right, so when the terminal side and the horizontal side are positioned along each other, when they are both horizontally positioned, then the angle between them is 0 degrees. Only when the terminal side moves from the horizontal position, moves up, or it can move down as well. So the amount of rotation it makes from the initial side is the measurement of the angle. All right. Now, angles are classified by their degree measurement. So there are some special angles that we need to know about. First one is a 90-degree angle. A 90-degree angle is also called a right angle, and that happens when we have the initial side, all right, and the terminal side intersecting at a measure of 90 degrees. In other words, we have the initial side, and then when the terminal side rotates and comes to a 90-degree angle, it's called a right angle. All right. Now, before we discuss some of the other angles, let's see what happens if I add another 90 degree from this point. So I'm going to just color the terminal side as blue. All right, I'm going to color the terminal side as blue. So what happens if the terminal side keeps moving and creates another 90 degrees from this position? It's going to come and fall here, right? It's going to move like this, all right? And it's going to come and fall. This is not quite a straight line, sorry about that, but it's going to be positioned in the opposite direction to the initial side, correct? So that would be 90 plus 90. So 90 degrees plus 90 degrees together, it will make 180 degrees. So what happens? This blue line and the red line has now formed a straight line. So any straight line has a measure of 180 degrees, and you will see that denoted like this, a straight line. This angle, all right, of the line is 180 degrees. All right. Now, the other types of angles are acute angles. Acute angles have a measure less than 90 degrees. So here we go. If we draw some angles less than 90 degrees, these purple lines, it could be a 60-degree angle, a 30-degree angle, a 45-degree angle, a 20-degree angle. They are all, as long as they are less than 90 degrees, they are considered to be acute angles. If an angle is greater than 90 degrees, all right, that means the terminal side would be somewhere here, 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 right? As long as they are greater than 90 degrees but less than 180 degrees, it would be regarded as an obtuse angle. All right, so acute angle has a measure less than 90 degrees. Obtuse angle has a measure greater than 90 but less than 180 degrees. So here are the different types of angles shown with diagrams. The first one was a right angle, and that angle has a measure of 90 degrees, so x equals 90 degrees. However, to denote a 90-degree angle, we create kind of a box here at the at the junction point of the two rays. All right, and the symbol, this particular symbol, is used to indicate right angles. Then we learned about the acute angles. Acute angles are angles that measure less than 90 degrees but greater than 0 degrees. All right, so 0 to 90 degrees, any angle between 0 and 90. If it's 90 degrees, it becomes a right angle. So anything between greater than 0 degree and less than 90 degree is an acute angle. Obtuse angles are measures between 90 degrees and 180 degrees. Typically, it looks like this, all right? And then straight angle is a line essentially. It's 180 degrees. So a straight line has 180 degrees in it, all right? A few other types of angles, the first one being adjacent angles. What are adjacent angles? They are angles that have a common vertex and a common side but no common interior point. So let me draw a figure to show that. So let's say we have the initial side here and then a terminal side here, all right? So we have the initial side and the terminal side, and they have a common vertex, right? Vertex is the point where the two rays meet. This is a vertex. Now, if there is another angle, all right, like this, and let's use a different color this time. All right, this angle here formed by another ray, then this angle, and so let's just mark it. This, let's say this is A, this is C, and this is D. All right. So the angle here, which is CBA, all right, or ABC. Normally, we put the point, the vertex point, at the middle between the two other points. So we call this angle ABC and angle. So here, angle ABC and angle CBD are adjacent angles. All right, so there are two angles being formed with using the same vertex B. So that's angle CBD. Yeah, and they would be considered adjacent angles because they share the same vertex. They share the same vertex and a common side. So which is the common side between the blue angle and the green angle? The side BC, correct? And the common vertex is B. So in these cases, these two angles would be called adjacent angles, right? So let's see, what is the other type of angle? Complementary angles. Two angles whose sum of their measures is 90 degrees are complementary angles. So let me draw again a figure of what a complementary angle would look like. So here we have the initial side and then a terminal side, and let's say this angle is 60 degrees. All right, this is 60 degrees, and then I draw another angle here which is 30 degrees from from this terminal side. All right, 30 degrees. So 60 degrees plus 30 degrees is a 90 degree, correct? So these two angles whose sum of their measures is 90 degree, these two angles would be called complementary angles. And then finally, supplementary angles, two angles whose sum of their measures is 180 degrees. Just the way we created complementary angles, we can create supplementary angles, and the sum of their measures would be 180 degrees. They are called supplementary angles. All right. Now here's an example of determining complementary and supplementary angles. In the figure, we see that the measure of angle ABC, again, they haven't really given us a figure. It's in the next slide, so we'll just have to wait for the figure. We see that measure of angle ABC is 31 degrees, and these boxes are actually supposed to contain the symbol for angle shown this way. Somehow it didn't show up the symbol on the slide. All right, so angle ABC and angle CBD are complementary angles. So complementary means that the sum of those two angles will equal 90 degrees. Complementary angles add up to 90 degrees. So determine angle CBD. So they've given the measure of one angle, and they say the sum of both angles is 90 degrees based on the fact that they're complementary. So we have to find the angle CBD. The other part of the question is angle ABC and angle CBE are actually, this is a typo here. It shouldn't be complementary, it should be supplementary, is what I found out later on. So I'm just going to replace it and write it as supplementary. Just a second. Supplementary angles. Supplementary, and that should have two P's. So supplementary angles. So angle ABC and angle CBE are supplementary angles. Supplementary angles add up to 180 degrees. Determine the measure of angle CBE. So we're going to work on the first part first, and then we are going to see the solution of the second part. But supplementary angles add up to 180 degrees, right? So we'll go through the solution, but first let's look at the figure that they talked about in the previous slide. So over here, here's the figure. We see several angles here, but ABC is has a measure of 31 degrees. The vertex point is B, and there are B is the initial side, BC is the terminal side, right? And then we have another ray going straight up from B, BD. And we also note that ABC and CBD are adjacent angles. Why? Because they have a common vertex as well as a common ray, a common side. All right, both these angles. So we have here angle ABC is 31 degrees, angle ABD is 90 degrees, and then we have angle CBD is what we need to find. That's X degrees, let's say. All right. Now, how do we know that ABD would be a right angle? All right. From the fact that the sum of the two angles ABC and CBD are complementary angles. So whenever you see the term complementary angles, or here complementary angles, that means the sum of the two angles is 90 degrees. All right. So here we have ABC and CBD. Given that they are complementary angles, then their sum must always be equal to 90 degrees. So that means this angle here, entire angle ABD, is a 90-degree angle. It's a 90-degree angle. All right. So if the entire angle ABD is 90 degrees and a portion of it is 31 degrees ABC, the question is asking us to find this portion of the angle. All right. So if we do 90 degrees minus 31 degrees, we will get, or we will know what CBD is. So they worked it out here. All right, measure of angle ABC plus measure of angle CBD equals 90 degrees. Then they replace the value of ABC, which is known as 31 degrees, and the measure of angle CBD, that's the unknown angle, X, is 90 degrees, right? And then the measure of angle CBD is calculated by solving for X, as in any simple equation. So you move the 31 degrees over to the other side, or subtract 31 degrees from both sides. So 90 degrees minus 31 degrees equals 59 degrees, and that's what angle CBD is. This is 59 degrees, and 59 degrees plus 31 degrees, you can cross check, should add up to 90 degrees. All right, given that they are complementary angles. So the next part of the problem was about supplementary angles. So it was angle ABC, whose measure is given. So that's measure of angle ABC, and CBE was said to be, these two angles were said to be supplementary angles, therefore they will add up to 180 degrees, right? So angle ABC and angle CBE are supplementary angles. So CBE would be this angle here, all this angle. All right? So if again they are adjacent angles, they have a common vertex B and a common side, correct? ABC and CBE have a common side, BC, or a common ray, which is BC. Again, it's the same process. You have to create an equation, so to speak, but this time on the other side of the equation we have 180 degrees because supplementary angles add up to 180 degrees. So measure of angle ABC plus measure of angle CBE together equals 180 degrees. Substitute your 31 degrees for ABC. The CBE is what we need to find out, equals 180 degrees. So just solve for the missing angle value, angle CBE, by subtracting 31 from 180 to get a value of 149 degrees. So this angle here is 149 degrees, this entire angle CBE. All right, CBE. So this is an obtuse angle. 149 degrees is a measure greater than 90 degrees but less than 180 degrees. That's what an obtuse angle is. And ABC is an acute angle. It is less than 90 degrees, greater than 0 degrees but less than 90 degrees, and that's is what an acute angle is by definition, right? Now, a few more facts about angles. When two straight lines intersect, the non-adjacent angles formed are called vertical angles. All right. So over here in the diagram, we see two lines intersecting each other, and it forms four angles, right? When they intersect, they're forming four angles, 1, 2, 3, 4. Now, angle 1 and angle 3 are vertically opposite. They are angles opposite or across from each other. 2 and 4 are also vertically opposite. All right. So we have what's called vertically opposite angles. Vertically opposite angles. And vertically opposite angles are always equal to each other. Always equal to each other. So the measure of angle 1 will be the same as the measure of angle 3. So if you know the measure of angle 1, let's say it's 30 degrees, then measure of angle 3. Even if they don't give us the value of that of angle 3, we will know immediately it will also be 30 degrees just by virtue of it being vertically opposite to angle 1. Same thing for angles 2 and 4. Now, angle 1 and 2 are, however, adjacent angles, correct? They are adjacent angles. They share a common vertex and a common side, common ray. So, what would be the sum of 1 and 2? 180 degrees. They are supplementary angles. Same for angles 4 and 3, adjacent angles. However, vertically opposite angles are 1 and 3, 2 and 4, and they will always be equal to each other. Now, another kind of line is called a transverse line. It is a line that intersects two different lines at two different points, and it's known as a transversal. So here we have line 1 and line 2, and we see they are running parallel to each other, and this line intersecting both the lines, both the blue lines, parallel lines, is called the transversal. All right, and it meets the two lines at 2 points, and it forms 8 angles. So there's angle 1, 2, 3, and 4 formed with L1, line 1, and 5, 6, 7, 8 formed. These 4 angles are formed with line 2. All right. Now, when a transverse intersects two parallel lines, the angles that are formed have some special relationships. We already know that there are vertical angles, vertically opposite angles, so to speak. So 1, 4, and 3, 2 are vertically opposite angles. 1, 3, and 2, 4 are adjacent angles, and same with the angles on line 2. 5 and 8 are vertically opposite. 7, 6 are vertically opposite, and 5, 7, and 6, 8 are adjacent angles. However, there are some other relationships between angles that we will discuss in the next slide. All right? So, when a transverse intersects two parallel lines, one set of angles that have a special relationship are alternate interior angles. So, in this picture here, 3 and 6 are alternate interior angles. All right. So, interior meaning they are inside within these two parallel lines. So, and they are alternate because 3 is here and 6 is on the other side. So, it's on the alternating side of the transverse, and they are inside the two parallel lines. So angle 3 and angle 6, and these two measures of the angles will be equal. That's the special relationship. The alternate interior angles will be equal. So 3 and 6 are one set of alternate interior angles. 5 and 4 are the other set of alternate interior angles. All right. So one set would be, or one type of angles would be the alternate interior angles, which are interior angles on opposite sides of the transversal. All right. So 3 and 6, 4 and 5 are angles inside within these two parallel lines and on the inside portion of it, and the angles are on either side of the transverse. That's what makes it alternate and then interior angles. The other set would be the alternate exterior angles. Exterior again meaning outside, on the other side of the parallel lines. Outside, therefore exterior. So 1 and 8 are alternate exterior angles on opposite sides of the transversal. Again, exterior meaning outside of the parallel line. So 1 and 8 would be one set of alternate exterior angles, and 7 and 2 would be the other set of alternate interior angles. So angle 1 and angle 8, and then angle 2 and angle 7, and again the relationship between these angles is that they will be equal. So alternate exterior angles on two parallel lines intersected by a transverse are equal. All right, that's a theorem. And then there's the corresponding angles. One interior and one exterior angle on the same side of the transverse. So 1 and 5. See, earlier we were talking about alternate. They are on the opposite sides of the transverse. Here, in corresponding angles, they are on the same side. So 1 interior, 5 is the interior angle, and 1 is the exterior angle, and they are on the same side of the transverse. On the other side, the corresponding angles would be 2 and 6, right? 2 and 6, they are on the same side. So these are some of the special angles, and the relationship is that they are equal. All right. Now we've already talked about the relationship between the special angles formed on parallel lines cut by a transversal. So when two parallel lines are cut by a transversal, the alternate interior angles have the same measure. They're equal to each other. And then the alternate exterior angles have the same measure, and likewise the corresponding angles will also have the same measure. So they'll be equal to each other. That's what we already mentioned in the previous slide. Now here's an example of determining angle values when two parallel lines are intercepted by a transverse. So here it says the figure shows two parallel lines cut by a transverse. Determine the measures of angle 1. All right, so it wants us to find the measures of angle 1 through angle 7. That means all the angles that are formed around the parallel lines intercepted by the transverse. So we have 8 angles here, 1, 2, 3, 4 around line 1, and 5, 6, 7, 8 around line 2. And the only angle measure that's given to us is the 52-degree angle for angle 8. All right, so using this information, we have to find the rest of the angle measures. However, we will be using some of the rules, the theorems that we learned about the relationship between the different angles. All right. So let's start with the 52 degrees, the one that's given to us. Now we know that vertically opposite angles are equal to each other. So angle 6 and angle 8 are vertically opposite each other. So if angle 8 is 52, then angle 6 will also be a 52-degree angle. So I'm going to mark this as a 52-degree angle. So we already found one angle without doing any calculations. Now, if we find angle 7, then we should also be able to know angle 5 because they are vertically opposite angles. So how can we find angle 7? We see that angle 7 plus angle 8, all right, since it's around a straight line, it has 180 degrees. Angle 7 plus angle 8 add up to 180 degrees. So if angle 8 is 52 degrees, then we can find angle 7 by subtracting 52 from 180, and that's what I have to do. So again, let me tell you what I'm doing. This entire angle here, this entire angle around the straight line, around line 2 is 180 degrees. So if we know that one side is 52, one of the angles is 52, then angle 7 would be 180 degrees minus 52 degrees, that's 128 degrees. So angle 7 has a measure of 128 degrees, and immediately you know that 5 being the vertically opposite angle will also have a measure of 128 degrees. All right, now let's look at the angles around line 1. We're going to use the relationship between alternate interior angles first. So which are the alternate interior angles? 3 and 5. So we know the value of 5, angle 5 is 128 degrees, and so 3 will also have the same value, 128 degrees, being alternate interior angles. All right, they are interior because they are in the inside of the lines, and alternate because they are on opposite sides of the transverse. Same thing for 4 and 6. Those are the other set of alternate interior angles, so if they will be equal. So if angle 6 is 52 degrees, 4 will also be 52 degrees. 52 degrees. All right. And then for 1 and 2, we are going to use the rule about vertically opposite angles. So 4 and 2 are vertically opposite angle. So if 4 is 52 degrees, then 2 will also be 52 degrees. And same for 1 and 3. 3 is 128 degrees, therefore 1 will also be 128 degrees. So now we got all the angle measures figured out. All we needed to do was calculate one angle, and then for the rest of the angles we just use our knowledge of the relationships between angles when two parallel lines are intercepted by a transverse. So this is the solution for the problem that we just solved previously. It's the same measures that we found for each of these angles. So I'll leave it up to you to take a pause at this slide and understand how they are figuring out the values of the different angles using the relationship between angles. But I think I have explained pretty clearly in the previous slide how to go about working and finding the solution of this. All right.